All right, guys. Okay, problem number 3. Problem number 3 is a little bit trickier because now we're dealing with a parent and mom. Okay, here's mom. She is now heterozygous, so she has 2 different types of genes. The other problem, okay, we didn't have an option, right? Dad, okay, is homozygous dominant, so he has 1 type of gene. All right, so because dad can pass on a big B, right? That's the only thing he can give, right? Mom, okay, can pass on a little b or a big B, okay? So to organize ourselves and make sure that we don't make mistakes, okay, what we're gonna use is we're gonna use a Punnett square, okay? So remember, dad is only gonna make 1 type of sperm, okay? Right? Because he only has little b's to put in those things, okay? Those are his bullets, okay? He only can load them up, okay, with this dominant gene, okay? Because that's all he has. But mom has 2 different genes, so she can make eggs, okay? Eggs that have either a dominant gene or eggs that have recessive genes, okay? Now, we're gonna make a table to organize our results, okay? And now, if this sperm fertilizes this egg, then we will have an outcome in which the kid will be homozygous dominant, okay? Because we went here, right? But if this sperm fertilizes this egg, now we have a different possible outcome, okay? Right? So our kids, what will they look like? There's 2 possible outcomes. They can be homozygous dominant or heterozygous. So now, when we look at our test questions, what are the chances of the offspring being homozygous dominant? Well, remember, there's 2 possible outcomes. Okay, big B is 1 of 2. Okay, 1 of 2, which is the same as 50%. So these parents have a 50% chance of having a child with a homozygous dominant genotype. Homozygous recessive, okay, is 2 recessive genes, little b. Notice there is none of these is this outcome. So therefore, it's a 0% chance. And finally, heterozygous. 1 of 2 are the outcome. Therefore, it's 50%. So it's like flipping a coin. Okay, mom and dad, when they have a child, okay, they will have a 50% chance of having a homozygous dominant genotype, or they will have a 50% chance of having a heterozygous genotype. Okay? Now, let's take a look at the phenotypes. Okay? The phenotypes. What color eyes will they have? Well, remember, big B, big B. Both of these outcomes will give you brown eyes, okay? So therefore, 2 out of 2 possible outcomes is the same thing as 100% chance. Remember, just because the little b's there, that doesn't mean that this person will have blue eyes, okay? This is dominant, okay? Therefore, this person will have brown eyes. Okay, now blue eyes, what are the chances of them having blue eyes? Remember, the only way you can have blue eyes is if you're homozygous recessive, little b. Therefore, okay, it's a 0% chance. Okay, so whenever you have a parent with 2 types of genes, you must do a Punnett square. This is called a Punnett Square. And that will organize, okay, your genes in a table, and it will give you the possible outcomes. If you're good at reading your genotypes, you'll be able to come up with the accurate answers.